Dear students, if you have just completed your O level or IGCSE physics exam and now you're transitioning into an A level physics student, then this is the very first video that you need to watch. I'm Ali Wahid. This is Omega Education, the platform for O and A level physics. Alright, students, so the thing is, I have compiled these workbooks for each and every chapter. I'll be solving on these. Like, if I scroll down here, we start off with the first chapter after the introduction. So we start off with the first chapter. There would be learning objective, data sheet, formula sheet, and here we start off with the topics. After each and every topic, there would be some of the sample questions, so you can go through like the questions that you are asked in the exam from that specific topic. Alright, so you should be having a better idea what kind of question you will be asked from that topic in your exam. So, bit of an introduction first of all for the students who will be choosing A-level physics. Defining physics, I mean at O level you should be already able to define physics. It is the study of matter, energy and their interaction. 5054 was the syllabus code for O-level physics. 0625 was the syllabus code for IGCSE physics. For this one, for O-level physics, A-level physics, you'll be having 9702. Important sites, not going to write it down, just going to narrate it. GC guide for past papers. Then you have some of the YouTube channels as well, other than this one, the one that you're watching right now. You have ET Physics, a very good channel, and there are some others also. For the official updates for the syllabus and stuff like that, you have Cambridge website. You can download the syllabus from there. Okay, so let's move on to the main thing. All right, so first of all, students across AS and A2 all together collectively they will appear for 5 components or 5 papers. The 3 of them they'll have it in AS, and the remaining 2 they will be having in A2. The first component that we call paper 1, just like you have in O levels, paper 1, that consists of same marks, 40 marks for paper 1, but the total time is different. So you have 1 hour and 15 minutes for this one. 1 hour and 15 minutes. The paper is of MCQs. For AS physics, the weightage of this one would be 31% for AS. Like when you'll be getting your AS physics grade, in that grade 31% of your grade would be based on paper 1. Here we have paper 2, and this is going to be of 60 marks. Right, in O-level physics we used to have the paper 2 and that was of 80 marks, but this one is only of 60 marks. So you have to complete it in the same time, 1 hour and 15 minutes. Question type, structured questions. Alright, so those who have appeared in O levels, they would be very much familiar with it. What do we call the paper 2? Structured questions. The weightage is 46% of your AS grade would be based on paper 2. 46% of AS grade. Then you have the paper 3 that is called advanced paper skills. So you have P3. This P3 is called advanced practical skills. So you'll actually need to perform the practicals, take the reading, so it will be an actual practical paper, not ATP, alternate to practical. So this is called practical skills, and this paper would be of 40 marks, and you'll be having 2 hours for it. The weightage is 23% of your AS grade would be based on this. Alright, so all of these weightages, these are for your AS grade. So 31% from paper 1, 46% from paper 2, and 23% from paper 3. Collectively, they would determine your AS physics grade. Then in A2, you give the remaining 2 papers. First one, paper 4. Now we call paper 4. Alright, so the red ones are for A2. This one is 400 marks, and you'll be having 2 hours for it. That is also consisting of structured questions. 38.5% of your A-level grade would be based on this one. 38.5. Then you have paper 5, 30 marks, and you'll be having 1 hour, 15 minutes for it. Planning, analysis, and evaluation, and that is like 11.5% of your A2 grade, all right, would be based on this one. All right, so the weightage criterias, I mean, they're in a different way, because sometimes they are referring to the weightage for the AS only, and sometimes they're referring to the weightage of the entire A level. So you need to be able to differentiate between these two. And if we compare the weightage of AS in A2, you should keep in your mind the AS in A2, they have 50%, you have 50% weightage of AS in your final grade that you receive after like 2 years after A2. In that final grade, 50% of that grade comes from your AS, and 50% of that grade is determined by your performance in A2 physics. So this is for the second part we have for A2. Alright, so this was about the weightage, about the papers, and each and everything. So the thing is, the easiest way for you guys, especially the ones who are just coming from O levels and they'll be starting off with AS physics, the easiest way is you download this workbook. Where do you download it from? You can download either from Patreon, you can download it from there, or I'll be uploading it on a Google Drive and I'll share the link as well. These workbooks, they took a lot of time, especially to add the sample questions after each and every topic. I have to like scroll through many of the past papers, sort out the relevant ones, and plug it after each and every topic, and then all the formatting and each and everything. So it takes a lot of effort. So that's the only reason that I'm charging a very minimum amount against these workbooks. If you download it from Patreon, you can get a subscription for like $5. Everything that I'll be uploading over there, you'll be having access to it. It would be better for you if you just note down during the lesson, note down and fill those boxes, fill those spaces, so you can have your own personalized notes. So if I show you the sample of this one, physical quantities, and this one is derived quantities in terms of base unit. So I'll be completing all of it, and if you have this sheet of paper, this workbook is like 30 pages, so you can note it down in a very organized way, in a very tidy way, followed by some of the sample questions. Here you can see there are some of the sample questions. So that's the next topic. I'll be solving some of the stuff over here, followed by some more sample questions, followed by next topic, followed by some more sample questions. So Otherwise, I mean, it's not compulsory. You want to just note it down on a blank sheet of paper, you can do it that way, whatever way you're comfortable, but that was just a suggestion. Let's talk about these papers first. Like I said, I'll be starting off with the first chapter first. Let us talk about the papers. Here we have the first one, paper 1. Now, to be very honest, I've seen many teachers telling the students on the very first day that you have the paper 1 that is very challenging, it is very difficult, and students, you guys are going to struggle a lot in the paper 1. So there's a lot of myth regarding this component. And like I said, to be very honest, this is just a myth. If you have done fair enough, at least fair enough in O levels, paper 1 is just like the paper 1 of O levels. The thing is, you would find it difficult if you're not following important things. Like, you should be informed from the very beginning, from the very first day. What are those things? Number 1, you would have, like in O level physics, you have at least 2-3 years to prepare for all these components, and you have only 3 components for entire O levels. So even for paper 1, you have at least 2-3 years or 2.5 years. You give your exams in O3 or your final year of IGCSE, and then you have, by that time, you have done a lot of practice of that paper, and that's the only reason that it would appear easier compared to paper 1 of A-level physics. The thing is, if you start off practice of this paper from the very start, and what is the very start? This is the time. This is exactly the time that you need to start from, your summer break. If you guys are wasting time of your summer break not studying physics, then it may no longer be a myth, and you would actually be struggling in paper 1. So you gotta start it from the very beginning. You would hardly be getting 7 to 8 months in which you have to complete the syllabus. So now is the time that you need to start off with the topics, and with each and every topic you gotta solve paper 1 questions. So if you'll be following this course, once I start off with the chapter number 1, which is the very next video, with each and every topic I'll be solving at least 3 to 4. So you gotta practice from the very start. You practice from now, and paper 1 would no longer be, as the myth is very difficult. So a matter of fact, I should be showing you, if I show you like one of the very recent past papers, especially P1 of A-level physics. Alright guys, so here I have opened the paper 1. It is from 2022, one of the most recent ones. If you have prepared well enough in O levels and you start preparation of A levels right from the start, and that means from the summer break, this would be pretty easy for you. Matter of fact, it would be one of the most interesting papers. Like, it would actually be very pleasing to solve these questions. So let's try some of these questions. It is from 2022 paper. What could not be a measurement of a physical quantity? This is the first question. You have studied this thing already in O levels, that a physical quantity has to be represented by a magnitude plus a unit. So 10 magnitude Kelvin unit is there, 17 magnitude, and there are some units, terameters prefix can be there. Alright, so the thing is, if I break down this one, 11 is the magnitude, and joules is the work done. Work can be written as F into D. The unit of F is newtons, the unit of distance or displacement is meters. So Newton, meters, times per Newton, per meter. Now you'll realize that Newton gets cancelled out by per Newton. Per Newton simply means 1 over Newton, okay? And meters gets cancelled out by per meter. And you're left with magnitude only. There's no unit written along with the magnitude. Okay, so it's just like I'm writing 20 kilograms followed by per kilogram. There's no unit for that. I mean, kilogram would be cancelled away with per kilogram and you'll be left with magnitude only. So this cannot be a physical quantity. So the point is, you have studied this concept already in O levels, but here you have just a variation of it. Here you have the second one. A computer memory is labeled as having a storage 128 gigabytes. Okay, what is the equivalent storage capacity? 128 giga stands for, the prefix is 10 raised power 9. You have these prefixes in O level physics as well, and then you can convert it into standard form. Matter of fact, if you write it as it is on your scientific calculator, you just write it as it is, it would automatically convert into scientific form, the standard form. It will be followed by into 10 to the power 11. Okay, so you just choose the relevant option from there. Which statement describes the precision and accuracy of the weighing scales? Okay, so this is something that you have not studied in O level physics, but it just take 2 sentences to get a basic idea of precision and accuracy. Precision is if the readings are close to one another, like these readings, the measured values are close to one another, the reading would be precise for that given range. And if these readings are close to the actual value, then the reading would be accurate. That's the only difference. Readings being close to one another, that would be precision for the given range, and reading being close to the actual value would be the accuracy. So you see, the readings are close to one another within 0.1 kilograms, so we can say that these are precise, but these are not within 0.1 kilogram of the actual reading. They're very far from the actual reading. Matter of fact, there's a difference of like 5 kilograms. So it is precise but not accurate. So there's a difference of maximum 0.1 kilograms, and they are very close to each other. The readings are very close to each other. They are precise, but they are not close to the actual value, so they are not accurate. And we study all these details in chapter 1 also. And likewise, we have another question. Let's say question number 4. Which statement about scalar and vector quantities is correct? Now, is that something that you have not studied already in O levels? So we have vector quantity, magnitude and direction. Scalar has only magnitude but no direction. There's nothing new over here. How can you find acceleration from the graph? So acceleration is something gradient of velocity time graph. Now tell me, do we not study that thing in chapter number 2 of O level physics that you guys used to call kinematics? They then changed the name according to the new syllabus. They changed the name to motion. Have you not studied this thing that you can find the acceleration of an object if you find the gradient of velocity time graph? It's just the same thing. You see, we have solved like first 5 questions from this paper, and it's not like I've compiled 5 easy questions just to clear my point. I mean, it's just from the past paper. So the thing is, if you practice from the start, this paper would not be a tricky one. Matter of fact, it would be one of the very interesting papers. Like, it would be actually a thrill to solve these questions.